In the expanse of the night sky, a colossal crimson star, one of the most brilliant and easily recognizable celestial objects, dominates the horizon. Positioned in a location far beyond our comprehension, it has the potential to emit an amount of energy that could rival the combined output of countless stars. This vast cosmic entity, potentially on the brink of a cataclysmic event, could soon release one of the most extraordinary bursts of energy ever seen, an eruption that might outshine a billion suns. Are we ready for the fallout that such an occurrence could cause? This immense red star, frequently called Goliath, lies in close proximity to Earth and has become a topic of intense interest and debate among both scientists and the general public in recent years. It has recently undergone a significant transformation, which has sparked considerable concern within the scientific community and fueled discussions about its potential future. The most worrying scenario is that this alteration may be the early indication of a supernova, a catastrophic stellar explosion signaling the end of the star's life cycle. After depleting its nuclear fuel, the star could collapse under the weight of its own gravity, resulting in a catastrophic explosion. The mere thought of such an event raises alarms, not just among researchers, but also for those of us living on Earth, as the possible dangers to our planet could be immense. This particular star, easily identified in the sky by its intense red color, is known as Alpha Orionis. It holds the title of the largest and most luminous star within the Orion constellation. Through instruments like NASA's Hubble Space Telescope and other observatories, astronomers have been monitoring the star's behavior, and in 2019 it experienced a drastic loss of mass. This kind of event is rare for stars of this nature and has captured the fascination of astronomers globally. While the Sun regularly goes through coronal mass ejections, the peculiar event observed in Alpha Orionis has raised new questions about the final stages of massive stars and how they behave just before they reach their explosive end. As scientists continue to observe Alpha Orionis, they remain divided over its precise distance from Earth. Some estimates place it as far as 1,200 light-years away, while others suggest it might only be about 724 light-years distant. Determining the exact position of stars, like Alpha Orionis, proves difficult due to the vast distances involved and the peculiar properties of red giants. Regardless of its exact location, this star remains one of the most awe-inspiring sights in the night sky, radiating several times more light than our Sun. However, with this radiance comes a considerable drawback: its rapid consumption of nuclear fuel. The star is burning through its reserves at an accelerated rate, hastening its approach to the end of its life cycle. Eventually, it will run out of fuel, causing it to implode, possibly forming a neutron star or even a black hole, depending on how the explosion unfolds. A crucial question arises: could Alpha Orionis be a danger to Earth? If a supernova were to occur within a few light-years of our planet, the consequences would be devastating. A supernova can release a staggering amount of light, potentially outshining entire galaxies. This brings to light an important consideration. Even if Alpha Orionis is located at a considerable distance, the aftermath of its explosion could still have far-reaching effects. Interestingly, the most recent supernova recorded in our galaxy happened in 1604, and humanity has yet to witness another such event locally. However, in 1987, a significant supernova erupted in the Large Magellanic Cloud, located 169,000 light-years away. While this explosion had notable impacts on its surrounding environment, it posed no immediate threat to Earth. Yet these occurrences serve as a reminder of the immense scale and potential hazards associated with these cosmic explosions. The idea of a danger zone around a supernova, particularly one that might happen relatively close by, has raised concerns about the potential risks to life on Earth. However, when viewed in the larger context of the cosmos, Supernovae are relatively infrequent and smaller in comparison to the much more powerful gamma-ray bursts, GRBs. GRBs are far more destructive, capable of obliterating entire biospheres and inundating planets with lethal radiation. For instance, GRBs can destroy a planet's ozone layer, leaving it vulnerable to harmful radiation from its sun, which could have long-term effects long after the burst itself has passed. This looming threat has been a subject of recent research, which has uncovered new insights into the potential dangers posed by stars that end their lives in such spectacular fashion. When large stars explode in supernovae, they can emit brightness far beyond that of an entire galaxy. The sheer brilliance of these explosions leads to the question of what would happen if Alpha Orionis were to undergo such a transformation. If a supernova were to erupt, it could become the second brightest object in the sky, only behind the Sun in terms of visibility. Even though Alpha Orionis may be far from Earth, the explosion's energy could be so intense that it might even be visible during the day. Such a glaring display would create shadows in broad daylight, offering a striking yet unnerving spectacle for anyone witnessing it. While the visible light from a supernova is certainly striking, the real threat comes from the high-energy radiation that accompanies it. This radiation, typically in the form of X-rays and gamma rays, can have far-reaching consequences. One of the biggest concerns is its ability to deplete Earth's ozone layer. Without this protective layer, life on Earth would be exposed to dangerous levels of ultraviolet radiation, potentially leading to extinction events. And the dangers don't stop immediately after the explosion. Over time, the remnants of the supernova, including high-energy radiation and shock waves traveling at nearly the speed of light, would continue to pose threats. As this debris travels through the solar system, it could further damage the ozone layer, subjecting Earth to even more harmful radiation, which would intensify the risks. Furthermore, the long-term effects of a supernova's energy release could persist for centuries, potentially leaving lasting damage on the planet. Interestingly, some studies have suggested that Earth may have already been affected by supernovae in the past. Elevated levels of iron-60, a radioactive isotope formed in supernova explosions, have been found in deep-sea sediments and lunar soil, suggesting that Earth has encountered the fallout from a supernova event sometime in its geological history, possibly within the last few million years. At present, no supernova candidates close to Earth are believed to pose an immediate threat, based on our current understanding of gamma-ray risks. However, ongoing research continues to uncover new threats, particularly from supernovae that emit long-range lethal radiation. These supernovae occur when a star nearing the end of its life is surrounded by a massive disk of material. The shock wave from the explosion interacts with this disk, creating intense X-ray radiation that can travel vast distances through space, potentially affecting planets within a 150 light-year radius. Fortunately, no such candidates have been identified near Earth, but this research has provided new perspectives on the concept of the habitable zone, the region of space where conditions are ideal for life. It appears that this habitable zone may be more restricted than previously thought, with the outer regions of galaxies lacking sufficient star formation activity to sustain the development of rocky planets. Meanwhile, the inner regions, where stars form and die more rapidly, may pose their own risks due to the frequent occurrence of supernovae. As researchers continue to explore supernova remnants, they are discovering that the debris left behind by these cosmic events can give rise to new stars, creating stellar nurseries from the expelled material. This cyclical process highlights the interconnected nature of the universe, where the death of one star often leads to the birth of others. Additionally, supernovae have proven to be invaluable for measuring cosmic distances. Astronomers use Type Ia supernovae as standard candles to determine the distances between galaxies, refining our understanding of the universe's vastness. The remnants of supernovae, composed of the material ejected during the explosion, play a significant role in the formation of new stars. These remnants serve as stellar nurseries, where new stars are born from the gas and dust left behind. This process demonstrates the cyclical nature of stellar life cycles, where the death of massive stars provides the building blocks for future generations of stars. This ongoing cycle of creation and destruction drives the evolution of galaxies and contributes to the constantly changing structure of the universe. As astronomers continue to study these remnants, they are finding that new stars can form from the gas and dust in these regions, even years after the initial explosion. Supernova remnants, with their diverse and complex compositions, are some of the universe's most significant sources of heavy elements. Elements like iron, gold, silver, and uranium are created in the extreme conditions of a supernova explosion. These elements are then scattered into the interstellar medium, enriching the matter that will eventually form new stars, planets, and even life itself. Without these heavy elements, the solar system and our very existence would not be possible. Supernovae are therefore not just destructive events. They also play a vital role in the creation of the very elements that make up the stars and planets we observe today. Moreover, the study of supernovae has expanded our understanding of the universe's expansion. By observing the brightness of type Ia supernovae, which occur when a white dwarf in a binary system reaches a critical mass and explodes, astronomers can measure cosmic distances with remarkable accuracy. These standard candles allow scientists to gauge the scale of the universe, providing vital information about dark energy and the accelerating expansion of the cosmos. The ability to accurately measure cosmic distances has revolutionized astrophysics, enabling scientists to map out the structure of the universe on a vast scale. However, the potential hazards of these cosmic events cannot be ignored. Although the likelihood of a nearby supernova affecting Earth is relatively low, the long-term consequences of such an explosion could be far-reaching. As previously mentioned, supernovae release intense radiation, which could disrupt the solar system's environment. This radiation could interact with Earth's atmosphere, depleting the ozone layer and exposing life on Earth to harmful ultraviolet radiation from the sun. Without the ozone layer, survival on Earth could become exceedingly difficult, if not impossible. Furthermore, the shock waves from a nearby supernova could affect the structure of the solar system. These shock waves would compress the interstellar medium, potentially triggering the formation of new stars or altering the orbits of objects within the solar system. In the worst-case scenario, a nearby supernova could disrupt the delicate balance of the solar system, leading to catastrophic changes in planetary orbits and possibly even the destruction of Earth. The study of supernovae and their remnants also raises fascinating questions about the future of the universe. As stars die and supernovae occur, the remnants they leave behind can eventually form black holes or neutron stars, some of the most mysterious and extreme objects in the cosmos. Black holes, in particular, are regions of space where gravity is so intense that not even light can escape. They are thought to be the final state for the most massive stars, and their formation remains one of the most intriguing phenomena in modern astrophysics. Despite their destructive nature, supernovae are essential to the ongoing evolution of the universe. The materials they release into space serve as the foundation for future star formation and the creation of new planetary systems. As new generations of stars are born, the cycle of stellar life and death continues, driving the evolution of galaxies and contributing to the ongoing expansion of the universe. In conclusion, while the potential threat of a supernova explosion remains a distant concern for Earth, the study of these events is crucial for advancing our understanding of the universe. Supernovae not only shed light on the processes that govern the life cycles of stars, but also provide critical insights into the chemical makeup of the cosmos and the way galaxies evolve over time. As we continue to explore the vast reaches of the universe, our comprehension of these dramatic cosmic occurrences will deepen, offering us a clearer picture of the universe's past, present, and future.